Welcome back, everyone, to another installment of Introduction to Insect Taxonomy and Identification. Today, I wanted to do another group of extinct insects, the Meganisoptera, and these are the giant dragonflies, quote unquote, that you see displayed in, the before the dinosaurs documentaries, ancient Earth documentaries, things like that. The largest insects that ever flew, stuff like that. And I say quote unquote dragonflies because they're not actually dragonflies. These are actually called the griffinflies, and they are a completely separate order. So going into our taxonomic tree, we have the pre-insects, the Entonatha, we have the apterous insects, the insects that never developed wings, and then what we're interested in are these Paleoptera. And within this group, we have the Odonata, which are the modern dragonflies and damselflies. The Meganisoptera are a relative group to the modern odonates, and they are considered a branch relative. They actually branched off earlier, so they would be, coming off of the branch here if they were still around. And they were mostly present during the Carboniferous and Permian ages, and this was before the dinosaurs. And this is, if you've been going through these talks, this would be around the same time that the Paleodictyoptera were also flying around, those insects that have 6 wings instead of 4. So these are the griffinflies. Let's take a look at them. This is what they look like. Overall, we actually know very little about them, about their biology, and even not very much about their structure, largely because there are very few specimens of these. I've said this before, that a lot of the insects that we know about from the fossil record are insects that we get from amber, because insects don't leave good rock fossils behind for various reasons. Go watch the video on the Paleodictyoptera if you want to hear more about that. But these guys tended to be very large. Not all of them. A lot of them were, thought to be regular size, like what we talk about when we talk about modern dragonflies. But they did tend to be pretty large as a group. And so you're not going to find a lot of these very, very large specimens in tree amber. So we're kind of limited to getting rock fossils of these. Luckily, for the few that we do have, because they were present during the Carboniferous, when a lot of these coal swamps were still alive, some of these can be found in pressed coal fields. Or they can be impressed into fossils in coal fields, but there's just not very many of them. The specimens that we do have of them tend to be wing segments, or sometimes you'll get a complete wing, and there are very few well-preserved whole body specimens. So frequently you'll get something like this, where it's just like one of the wings, or one good impression of the wings and maybe a little bit of the other wing. And it's pretty disappointing because you are very dependent on these rock impressions. But occasionally you'll get more of the body, and then very rarely you'll get stuff like the legs and parts of the head and stuff like that. So this is more of like an artist's rendition of what we think they looked like based off of the fossils that we could put together. There are one or two that are really well preserved and you have a full body. But they are exceedingly rare. So what do we think we know about them? Well, they were probably predators, just like the dragonflies and the damselflies nowadays. And they did get very, very large. I think the largest one belonged to family Meganeuropsis, and it reached a wingspan of 28 inches or 71 centimeters, so just over 2 feet. And from what little we can tell from like their head structure, so this would be a head fossil, and you can see it's really badly preserved because you have things like compressed sandstone fossils where it's just easily damaged and you can't really see a bunch. But with these researchers, you can still see they have these very, very large eyes. They have lateral and medial ocelli, so they, similar to the dragonflies, they have very, very small antennae, similar to the dragonflies. Here is the frons. You have the mandibles and the maxillae and the labrum up here. So you can kind of see the face. It's very, very similar to a modern day dragonfly. So we think they probably had the same feeding behavior as modern day dragonflies. So this is kind of an artist's recreation of that fossil, and it's not easy work when you're talking about these very poor quality fossils. So we think that they were probably predatory, including in the few nymphal fossils that we could find. Because they were so large, this kind of leads to this idea that, well, maybe they got really, really big because the Carboniferous and the Permian had higher oxygen levels. And this is true. There were higher oxygen levels. And one of the major limiting factors for insects is their kind of passive respiratory system. They don't have lungs. They have these things called spiracles and trachea. So they're largely dependent on passive infusion of oxygen into their body. So they do have limiting size because of restrictions on the amount of oxygen in the atmosphere. This wasn't the problem during the period that these guys were alive. And so that could be one thing. The other theory is why they got so big is because there were no airborne predators. There weren't aerial vertebrate predators yet. So there were no bats, there were no birds, there were no pterodons or anything like that. So these guys could kind of dominate the skies, and being this open niche, they could just kind of run away with it. So maybe that's why they were so big. So what are their other obvious differences between these guys and the modern day dragonflies and damselflies? Longer antennae in some of them. Some of them appear to have these very robust spiny legs, which you can kind of see in this fossil here. You can see some of the texture of these legs, much spinier than what you would normally see in modern dragonflies and damselflies. Big changes are in their wing venation. So here is kind of a line drawing of what variation there exists in these ancient Meganisoptera wing venation patterns. And this is very, very different than modern day dragonflies. So this is a modern day dragonfly wing. You can still tell that there's a lot of venation, and excess venation is a common characteristic of primitive insects. Generally speaking, going back to that cladogram, generally speaking, if we zoom out here, once you are talking about winged insects, as you go down the list, you go from high wing venation to low wing venation. So they make do with fewer and fewer wing veins. And then you get to things like some of the wasps and some of the flies, and they have very, very few veins in their wings. So the more primitive insects, like the Ephemeroptera and the Odonata, tend to have lots of wing venations. The Meganisoptera have taken that and turned it up to 11. They have tons of wing venation. They have tons and tons of cross veins, not super specialized lateral veins. And when you compare that to something like modern day dragonflies, dragonflies still have a lot of wing venation, but it is generally reduced. Other differences is that the Meganisoptera don't have a prostigma. All dragonflies have these prostigma on their wings, these black spots. And they also have this thing called a nodus. And the nodus is not present on the Meganisoptera. This nodus helps them fly. And it gives this bend to their wing, and it allows them to change direction faster. It allows them more maneuverability. And it allows them to go faster and go faster, stop faster, and turn faster. So they are much more aerodynamic than what their ancient relatives, the Meganisoptera, would have been. And unfortunately, that's about it. That's all we really know about this group of, the giant dragonflies, these griffinflies. There's not a ton of fossil evidence. We know that they existed. We know about when they existed. But that's all we can really do with it. We're not going to get a ton of fossil evidence of these like we would for some of those other insects I was talking about from the amber. There's just not as many of them. So it's pretty unfortunate for such a charismatic creature, but that's the way it is. And I'll talk to you guys later.